Hello, today I just want to talk about the pre-experiment for my next video. This is just a trivial experiment, and first I want to explain about the dataset. The dataset that I will use in this experiment is just DNS dataset. DNS stands for direct numerical simulation. In this case, this is the turbulence dataset. So the numerical simulation in this case is outputting the turbulence dataset like this. So in this case in here we have the case of periodic hills. Actually the hills in here is just a regular geometric shape. So this is actually just a sine wave. How I know it is just by trial and error actually. And in this video I want to explain how to mask this dataset. Oh yeah, why first I want to explain why we need to mask this dataset, because as you can see in the turbulence dataset we have of course the u and v components of the wind speed and wind direction, and in the hill part in here the value it will be 0, and if we apply them to the governing equation like this. First I think I need to explain the background why I do the experiment. Actually in the next video I want to experimenting with physics informed neural network again, but according to this paper here, according to this paper, we can use physics informed neural network to fill a gap in sparse dataset. So the setting will be like this. The input is just the coordinates, but we will talk about this later in the next video. Okay, so we just need to focus for the governing equation in here. We will use this governing equation here. So maybe you ask why we need this governing equation. Actually this is just to confirm if our dataset is valid. So the less the error from this loss function we got, then the more valid the dataset that we have, right? So that's why we did this. Okay, first I want to show you what happened if we didn't mask the dataset. Ah, wrong script. Um, uh, this is the right one. Here this is the u mean distribution, and as you can see here in the part of the hills the value of the u is 0, right? Yeah, it's obvious because basically, and it should be there's no data in here, right? Because this part is filled by the hill. So that's why imagine if we apply this full data set to this governing equation, logically we will get more loss, right? we, if we compare with when the data set is already filtered or already masked out. Here I will show you. Okay, I will comment out this. This is the masking part. Let's clear this. And as you can see here, we got the mean and standard deviation like this. And this is actually the final value here. This is the final loss. So we got 2.4. Now we can judge if this value is high, or we can judge if this value is high or low. We need the comparison, right? So we need to comment in this. uh no, yeah, this is the right one. And as you can see here, we got lower final tensor or lower final loss value. But look at the mean. As you can see, actually for the unmasked dataset, we got the lower mean for the epsilon or the loss. Oh, maybe you confused why we have the epsilon in here. According to this paper, as you can see, we got the equation that we use it in the experiment. So that's why I use all of them. Back to the terminal. Here we got the lower mean epsilon. It's because it's because in the part of the hill we got the zero value for the u for the wind velocity. That's why if we if we calculate the mean for all of them with this equation, automatically the mean will be lesser, right? So that's why we got the lesser in the epsilon. But if you see the standard deviation for the unmasked dataset, it's bigger, right? It's bigger if we compare with the standard deviation of the masked dataset. And that is how we got the lower value of the final loss, because as you can see here, we powered them by 2. So that's why standard deviation in here is important. Now I want to discuss actually how I do the masking. Honestly, this is very simple. I'm just produce the cosine here. I'm just produce the cosine here plus a flat section. I'm just produce something like this. So this is just a cosine wave. So this is the half part, and we got the end here plus the flat section in here, and then we got the reverse of this part. Simple, right? And here the show of the plot if we mask the dataset. As you can see, I think it's perfectly masked. We successfully masked all the hill parts. And maybe you want to ask why I'm sure this is the solution. It's because actually in the in this web page, they are explaining how they create their dataset. So basically, all the parameters of the dataset is included in the file name like this. And here, this is the dataset that I got for this experiment. And yeah, I think that's all. Like I said before, this is just the simple experiment. This is just trivial experiment. It's because this is just a pre-experiment for my next video. So the next video is the real experiment. Okay, see ya. Bye.